Hi, I'm Chris, and this is Light Inspiration. So I just finished up a personal project, and I'm about to move on to the next one. And I actually wanted to circle back and try my hand at a project that I had an idea for a while ago. So about a year ago or so is when I started exploring electronics and getting into 3D printing, prompted by my boss at work. And I grabbed a good idea notebook and wrote down some ideas. There's a bunch of them that I thought and still think would be good, but I just didn't know how to do them yet. Some of the ideas I started trying and realized I didn't know how to make a specific piece of that. So I thought of a different personal project that would isolate that one piece and allow me to learn that in detail, and then circle back and learn how to fit that into the overall project. This is one of those projects. So I wrote down in my notebook, and it's a little bit small, but the idea of having a treasure chest that has a little demon on the inside that would open it with its claw, maybe have light up lights and then close it, and then put a little sensor on the front so that when someone walks by, the demon would open. Maybe play sound, maybe rattle the box a little bit. I'm not totally sure, but the core functionality was opening and closing the lid of the box. And I didn't want to do just a servo that just pushed open a lid and wasn't attached. Because I knew that I also wanted to potentially do projects where maybe the lid was on the side and open like a drawbridge to open and close. And basically, I wanted discrete control over how the lid was opening and closed and not have to be dependent on gravity to hold the lid down. So I couldn't do that whenever I started. I tried laser cutting some parts to do the 4-bar linkage idea to open the lid, but I just didn't know enough about creating that, and created a couple of projects that kind of bent themselves in ways that weren't desirable and stuff. So I kind of set that aside and came back to it later. So now that I have a little bit better grasp of Fusion 360, I've been able to circle back to this project, not because I've gained a lot of knowledge about 4-bar linkages. I have a friend who told me about the idea, who explained it and actually gave me the pages to calculate the linkages, but I only have a really small period of time, usually in the mornings right before work, to work on personal projects. Sometimes in the evening, but the only dependable times in the morning. And I didn't want to get bogged down in too much stuff that I didn't quite understand, as opposed to being able to kind of feel it out. So now that I know Fusion a little bit better and I know how joints work, I went through and modeled out a simulation which will also be what I 3D print out and actually build into the box. It's not done, and really this is just a first pass at it. I'm probably going to throw this entire model away and start all over again whenever. So this is my side table at work, and one of the things on it is this treasure chest that I use to put extra 3D prints that I do whenever I'm not printing an actual job, that I set out here so the kids that come through the office can grab a toy. And I actually got this for one of my early projects, which was to try to make a box that would stay closed, and then I could program to have a sensor on the front and then open, and like have like a little thing on the inside that was lifting the handle and then close on command, and either run that from a sensor or run that through a socket connection so I could trigger it from a web app or a phone or something like that. But I was early enough in my electronics learning process that I didn't really know how to accomplish that, but I am getting close to there now. So here's a model that I rattled out last night. This is really just a rough sketch to get the concept into Fusion, and then I'm probably going to go back, blow all this away, and start all over again, and model out the actual thing. But I pulled a 3D model of a servo from GrabCAD that I have in my workbench, and then created a servo mount to mount it into the box, a horn mount, a servo horn mount, and then each of the arms for the 4-bar linkage that I wanted to build out, and then just little spacers for whenever I attach this to the side of the box. And then this box is a scale, a 2-scale model of that treasure chest that we looked at over on my side desk. So let's see. Let's pop open the analysis from the side. So what we can see from here are the bars, and I've got joints in on all the bars so we can grab the horn and move it around. There's something that I did that messed up the joints, or at least messed up the freedom of movement for the joints. So because I should be able to move it more than this, but I can't at the moment, and I think I really just added too many joints. But the general concept is now. Something else to point out is that I pulled out the whole model is parametric, but I pulled out the dimensions. Excuse me. I pulled out the dimensions for all of the bars into the user parameter, so I can come through here and make adjustments as needed to the bars and kind of feel out exactly how I want things to fit together. See. So the length of the 2 sets of bars, so the red bars and the blue bars are the long and short bars, and then they all have a consistent depth and width. So that's the whole thing, and I want to show how I built all this. So I'm going to pop open a new document and walk through how I created the bars and how I can adjust them using the user parameters. So I'm going to pop open a new document and define some of these user parameters. You could do this up front. I like doing it up front in this case because I know the things I'm going to want to be able to adjust without having to go back in the history, but you can also come through and add these in after the fact. So I know that I'm going to have a consistent bar width. We'll make it 3, and bar depth. Make that 3. Actually, let's kick this up to 5. And then I want 2 sets of bars. I want the long bar. I want the long bar length, which we'll do at 30 for right now, and then a short bar. We'll do that at 20, and then we can come back and adjust these as needed. So now that I have those defined, I'll create a new sketch. It doesn't really matter which plane that you're on, so we'll just start on this one. And the first thing that I'm going to do is to grab a center defined rectangle. You can hit S to bring up that little palette. And then I want this to be the bar width. And, oh, I forgot to switch over to dimension on the other side, so I'll do this, I'll do the long bar first. So now we have our bar defined, or the main body of our bar defined, so we just need those circular ends and the screw holes. So I'll grab a center diameter circle, and at one end of the bar, I'll just pull this out and hit the D key so that I can redimension it, and set that to the bar width as well. I mean, we could use a coincidence point to pull one of the edges of the circle to the edge of the bar, but we've already got the dimension, so might as well use it. And then, one thing that I forgot to define, which was the screw, which is a screw hole diameter. So I know that I'm going to use 3mm screws, and I'm going to give it just a little bit of clearance for the tolerance for my 3D printer. and we'll pop open another center point center point circle and put that in. So now we have one side defined, and I want it to be mirrored onto the other side. So rather than drawing all of this over again, I'm going to grab the line tool, which is just L on your keyboard, and put a line down the middle of this bar. So you can see that it has the midpoint dimensions here, so we know that it's in the exact center. I'm going to click on that and turn it into a construction line, because I don't really want that for the form of the shape that I'm making. I just want to use that so that I can then use the mirror command. So I'll select the two circles that I want to mirror, and then I will mirror it across that construction line that we just drew. So sometimes this will get you whatever you had selected before will be included in the objects that you select. So you can either come click back up here and then unclick that, so we're back down to two objects and now the line's free to mirror across, or you could just clear it out and select the lines over again. But either way, so we'll grab the two circles and then we'll grab that center line and we can see a preview of that mirror. So now that we have that whole thing set up, we can extrude that out into 3D space. I'll grab just the parts that I want. Notice how, because it is a construction line, it doesn't split this this part of the profile into two halves. And I'm going to pull it up to bar depth. Right, so we have one bar. And from here, we can go through and adjust things like, let's double that, make it a little bit hardier. So this is looking good. One of the things I forgot to do is turn this into a component, because I know that we're going to duplicate it. So I'm going to create a component from the bodies and call this long bar. So now we can come through and make a copy of our long bar. Whenever you do a move copy, one of the things that you want to do is immediately before you move any of the dimensions, click on create a copy, so that whenever you pull it out, you're actually pulling out a copy instead of moving the original long bar. So this creates a copy, and when I say copy, I really mean copy. So if we go through and change the, well, not even change the original sketch, if we go through and add a sketch and change the component itself, like if we put in the center screw hole that I forgot to add, and then extrude that, we'll use that to cut to the other side of the bar. And notice I'm using the to object and using the other side of the bar. That way, as we adjust the bar depth, this cut will continue to go all the way through. So if we go ahead and cut that out, notice that it gets added to the other copy as well. So now we've got two long bars, so let's go ahead and create the short bar. So instead of creating another body, this time I'll add a new component right off the bat and call it short bar. And I don't want to start from the origin plane here. I know that I'm going to want this to line up with the bars I just drew, so the new sketch that I'll be creating for short bar, I'll just use the top of one of the long bars. And that way you can see we're drawing on the top of the bar and not on, let's see if I turn the origin back on. We're drawing on the top, it's kind of hard to see that. We're drawing on the top of the bar and not on one of the origin planes. So now I will create a short bar. I don't really need to line this up with the long bars, but I'm going to do it just to shortcut a little bit of this because I only have a little bit more of lunch to finish recording this. So we'll do bar width. In this case, I'm going to start with the circles just to be a little bit varied in how I'm doing it. Make this a screw hole diameter. And then I'll grab another rectangle and hang it off here. Forgot to dimension it, so I'll hit D and make this short bar length. And then the last thing would be to make this dimension the bar width. All right. So same thing we did last time. I'll grab the line tool, throw a line across the middle. This time I'll leave it as a regular line. You don't actually have to turn it into a construction line. It's just kind of informative whenever you do turn it into a construction line, plus it doesn't split the profile. So I will then grab my mirror tool and grab the two lines that I want to mirror, and then that center line that I want to mirror across, and now I've got my short bar. So I'll extrude that into 3D space. And yeah, notice that because it's not a construction line, these are two separate profiles I need to grab now, and grab that last little chunk and make this bar depth. All right, and then like before, I can go through and create a copy of the short bar. All right, so we've got our 4 bars. They're all parametric. I can go through and adjust various settings and see them play through. Okay, just to give us a little bit more room. So now the last part is to joint these up. So right now these all move independent of each other, and that is not what we want. So we'll go through and start adding joints. So the joint that we need for this one is revolve. There are a bunch of different ways of jointing, basically joining 2 parts together and then defining the relationship between them as far as how they should move. So we want the revolve. We want these all kind of revolve around each other. So the basic steps are create a joint, pick a profile that you want to put it on. I want to get the center hole for that body, but it's covered by this one. So what you could do is you could hover your mouse over the profile that you want and hold down the Command key on Mac. It's maybe the Control key on Windows, I'm not totally sure. And then that will snap you into different points on that profile, and that'll allow me to grab that center circle, and then do the same for the underside of the other bar. So we get a little preview animation of it going around, and the sides actually matter. So we want to attach this profile to this profile. If we attached this top profile to the other top profile, it would flip one of the bars over on top of each other. So be aware of that. So, and this is a good time to come through and be able to check out the different types of joints that you have, to see exactly what they do to your parts. And these animations are fantastic as far as kind of getting an idea of a visual idea of what each of those joints do. So now that we have 2 of our parts joined together, we need to go through and tell Fusion which one of these parts that we should ground so that everything else moves relative to it. So if I grab these two parts that we joined together, you'll notice that it's one, we're not getting that revolve that we added for that joint. It's not revolving around anything. It's just moving the entire parts. And then 2, you can see by the shadows that we're moving the 2 parts in 3D space, and that's because we haven't told Fusion this part should be attached to the ground. So the way that we could do that is to right-click on one of the parts, and I'll do it on just the first long bar that we created, and you select this ground option up the top. So that will put a pin into this component, and it will attach it to the ground plane. And now we can move that second part relative to the other one because we know that the other one is going to stay put in the ground. So as we add in more joints to these parts, you'll see that everything is able to move in a way that we would kind of expect because this part is grounded. So you can also go through and unground parts if you want. You could go through and ground multiple parts if you wanted to, if there were multiple things that should really be pinned down that would affect the joints. You can go through and do that. So, but in this case, we just need 1 bar that's grounded. So I'll go through and start adding the other joints. So if you see, so this threw me whenever I first started using Fusion, the concept of capturing the position. So this happens because Fusion will allow you to pick up and move stuff around freely, and it doesn't record that in the timeline. So which is good. Sometimes you just want to you just want to move things around to get an idea of where they're going to be placed, or sometimes you're going to rotate because that's part of the functionality, but it doesn't actually need to be captured in the history. It's not You're not actually adding something to the steps necessary to create the assembly that you're making. So it allows you to free float these around, and then it'll ask you if you want to capture that position. So I've moved this part into a specific position and I want to capture that in the history, or if you want to just cancel it, so move it back to wherever it was before. If I hit capture position, you'll see down in the timeline I'll get a little capture position, and that takes a snapshot of all the pieces in the assembly as they are at the moment. And now whenever you go through and play back and forth, that position is captured. So in this case, I don't necessarily want that capture, so I'm gonna go ahead and delete it. So, but that's what that was. That threw me off for a while whenever I first started using Fusion. So now I'm going to joint up the second short bar. So we'll grab a joint here. We'll attach it to the top here. We'll get our revolve, and then we'll do the last part, which are the two holes on the second long bar. Now we have all of our pieces joining together, and because that first long bar is grounded to is set as ground in Fusion, I can grab this bar and get that rotation that I'm wanting, or get that movement action I wanted. And that's it. As I add that servo horn, I can unground this bar and ground the servo horn, or ground the axis, so I can move around what's grounded so that I could get that full range of motion. But this will allow me to come through here and test out the different bar lengths, adjust them if I print it out and the final version doesn't work the way I expected, and really just kind of like play and experiment in this consequence-free world before I take it to a 3D printer or a laser cutter and make something real out of it, out of material that I'm using up and potentially ruining, potentially incurring costs. So that's it. Hopefully that was helpful. It's going to take a while for me to build this project out. I usually do this in 30-minute sprints in the morning before I work. So I'm kind of pacing myself out and doing some research and reading and modeling, and then printing and doing tests and stuff like that. But I'll make sure that as I step through this project, I keep recording and updating the channel so that you can see what I build while I build. So hopefully that provided you some light inspiration.